at some of the advanced features in the program. We're going to start off with peak profile fitting. To begin with, I'm going to import the same spectrum you've seen before. It's mixed phase Hilarite specimen. And to get to the spectral peak fitting, we're going to go to spectral deconvolution. There's peak fitting and deconvolution methods here. So it's not just one thing that it does. And it's similar interfaces you've seen before. This interface of peak fitting is still playing around with making sure that the buttons are optimized. I see that the apply and reset buttons here are the same thing as below. I need to fix that. But we need to then define a background, and I'm pretty happy with that. Again, maybe we'll try a spline and see what happens. Well, let's reset that. I didn't like how that worked. There's the moving average. That's pretty good. Let's say apply that one. Does this button work? No, that button's broken. Apply. So there we have a nice background corrected spectrum. The background is always going to be shown there, so you know what the background looks like. Now we go to peak detection, and here you get to select anything that you want from the list provided: Gaussian, Lorentzian, pseudo-Voigt, Voigt, asymmetric Voigt. Again, this depends on what you want to do. I'm just going to pick pseudo-Voigt to begin with. Okay, now we can then start playing around with some peak positions, peak threshold. But usually you're going to want to pick your own peaks to begin with. There will be a button here, just like before, to automatically select the peaks for you. But a lot of times it doesn't work that great, and you end up selecting your own peaks anyway. So you just click on this interactive selection, and you just click anywhere that you want. Whoops, maybe I didn't want that one, but you just click on it again, and it'll go away. You don't have to press any buttons on the keyboard. You just click on it again. You don't have to be super perfect. Just keep going through and select the ones. And you also notice that it doesn't define, you don't have to define a range of fitting here. So some software, you have to say, I only want this peak to fit within this defined range. I've already built that into the algorithm to only fit the peak within a range of full width half maximum. And it evaluates what that range is for you. So now I'm just going to combine, because it only does the fitting on all the combined auto ones. So I'm just going to combine that. Clearly I've missed a peak there, but we'll see what happens. So now we go to peak fitting, and let's fit the peaks, see what happens. So there we go. That's pretty good for as a first pass. This gives you a total R squared value, and on the right, it gives you the total fit, R squared for the total fit, and it gives you the R squareds for each individual peak. And the last peak I added, it's not very good. You can zoom in on that. That has an R squared of, well, peak 3 has an R squared of 0. That's maybe we can just delete that one. Let's zoom in on this. Oh, I'm still adding peaks. I forgot to turn that off. Let me just get rid of that one. Disable it. I should add an automatic disable when you press the peak fitting button here to fit peaks. Let's zoom in on this region. Actually, that's not that bad. It fit pretty good. Pretty happy with that. Let's take a look at some of the other stuff. Okay. Yeah, maybe I could do better on the background fitting. This one's 540. It didn't like that shoulder that much. Might add some helper peaks to try and fit that, but maybe I can delete it. Oh, I see why this deleted, because it's too low, maybe, and it didn't really fit the baseline. And this is terrible. There's definitely another peak I need to add there. So let's do that. Go back to peak detection. Let's remove peak 3. Yep, peak 3 removed. And now let's add another peak here. Combine them. Okay, now disable. And let's do fit peaks again. Okay, that's a lot better. I've already noticed that it's much better here. Let's zoom in on that. Yeah, that's way better. Pretty good fit. The data is pretty noisy. Maybe I should have smoothed it a little bit before fitting, but overall, pretty good fit. We can then, so there's an output window here that gives you all the peak statistics here, centroids, amplitudes, the width of the peak, full width, half maximum, R squared value for each one. If you go to analyze results, the same thing is there. It's just in table form. And then you can export this to a file. So you can save that and do whatever you want with it. Deconvolution is a little bit more advanced. I'm still working on it. Where you can show like frequency spectrums and power spectrums, power density plots. You can apply high pass, low band pass filters. I'm still working out things to do with this. Mostly just playing around for the moment for a smoothing. Again, that might be a future smoothing technique in the future. Maybe for the cluster analysis work. We'll see. We'll see where this goes. But right now it's there, and yeah, that's it.